Hi, I like to show the use case object detection running on the ctrlx core. This is just the funny part. Let's start with the demonstration. Your task is to realize an object detection on a conveyor belt within an industrial automation. You have a conveyor belt with different objects installed and also a camera connected to a ctrlx core. The ctrlx core itself drives the motors and sensors or actuators. But now, how to get the model for the object detection? Then, the approach is just to take your mobile, take pictures from the object and deploy the trained model, which is done on the device, to a model repository. The model repository converts the model and delivers it up on a request to the ctrlx core for local inference. But how does this look like in real? So just install the AICV app. So this is a short demonstration about object detection can be done easily right on your ctrlx core by using a USB camera. The Snap AICV is already installed, and if you start it, it will open a new tab where you can choose different settings, if a TPU is available, and how to configure your image source. Also, the output node for the data layer is given. If you just hit start, the inference will start with a pre-trained model. It's a well-known mobile net model. So you can look around. The USB camera is directly connected to the ctrlx core. You see here a computer and here the cables for the USB connection. And additionally, the TPU accelerator is also connected to the ctrlx core via USB. I have here on the desk some additional automation devices. There is an IO-Link master with some sensors or actuators, a smart light and some grippers just to demonstrate the functionality which is connected also to the PLC. If when I uncover the ctrlx core, you see in the picture it's classified as the ctrlx core, and you see also the inference time. Now we have seen this by using a pre-trained model from Google. How can we train our model by ourselves? So the first step is to open with your mobile, and it's also possible to do it right here in the browser, the web-based application, a prototype to train two different objects. So you just take the scene for the first object, take some pictures, and for the second object take also some pictures. In the next step you hit train the model on captured photos. Then you can start the inference in the browser just to check if the classification runs well. And finally you hit convert model for embedded inference, and it will convert it to TensorFlow Lite and ONNX format. You will get a model ID, copy it, paste it to your local ctrlx core, and download the model with the specific ID. You can then start the inference, and now the inference uses the own trained model. You see here class 2, class 1, and now if you switch to the data layer, because the inference also has an output on the data layer, the score and the class, and change a different value and say, okay, I'm just looking for a specific class, and then turn on the red smart light, it will just work out of the box. Now, at the end, some details about the performance with and without using the TPU. You have seen there is a checkbox to use the TPU, which is connected via USB. If you just hit start, as mentioned, it will use a pre-trained model. You have a round trip time around 120 milliseconds. If we look on the CPU usage on the ctrlx core, you will see there are 4 cores and 2 cores are nearly completely used. These are the non-real-time cores. And if I switch on the TPU and look again on the performance, you will see that the round trip time is quite lower. And if we go back on the performance measure or on the usage measure, you will see that the non-real-time cores are used quite less. By the way, the real-time cores, core 1 and core 2, are used by the PLC, which always also runs here.